Okay, good morning, class. At this point, we have done the derivation of the compound angle identities on page 93. We also have introduced all of this, the grade 11 trigonometric identities as well as your grade 10 trigs. This lesson was done yesterday, but during that time it was load shedding. So there won't be much student participation at this point. Yes? No, the whole of number 1, so it's 1.1, 1.3, 1.5, 1, and so on. Okay. Yeah. Alright, so we spoke about co-ratios, we spoke about identities, and so on. Okay, so the compound angle identities is identified as this. That's also given on your formula sheet. Now, the compound angle, the compound angle identity proof is not required for examination purposes. Okay. However, if you want that, we prove the compound angle, the cos alpha minus beta on page 92 is written out nicely there. Otherwise, it's explained in last year's lesson. You will find that in the description box below. Okay. So at this point, you were exposed to knowing that cos. So the proof was for cos of alpha minus beta, which gives you cos of alpha, cos of beta plus sine of alpha, sine of beta. So that is your identity. So work example is this is example 1 on page. Example 1, and this on page 93. Okay. So here we are given the question says determine cos of 90 minus beta using the formula cos of alpha minus beta. So if we take that into account, that is what that formula is referring to. So in alpha's place, as you can see here, is 90, and in beta's place is beta. So in other words, this would be 90, and that would be alpha, which is 90 again. So if I do the cos expansion, it's going to be cos of 90 times cos of beta plus sine of 90 sine of beta. Okay, so initially it's a bit confusing, but just remember that cos of alpha minus beta is equal to, and this is on your formula sheet, it's the identity that was proven. At this point, it's going to become cos of alpha, cos of beta, plus sine of alpha, sine of beta. Again, in the sum that was given was cos of 90 minus beta is then going to be, if I see here alpha, I put a 90. As I did there. Okay. So remember, for the cos of 90, we take that to the graph. The cos graph, we spoke about that. Cos of 90, of course, is 0. Times cos of beta plus sine, we take that to the sine graph. Sine of 90, of course, is 1 times sine of beta. But we know that if we use a co-ratio, that is simply going to be sine of beta, not so. But they want you to now use your compound angle information. So if you look at that, the in simplified version is actually exactly that. So 0 times beta is 0. 0 times cos of beta, sorry. So the answer is this simply sine beta as we know it to be. Okay. Now we're looking at this here. It says derive the other formula using the cos of alpha minus beta. I'm just going to pull this there. So that is what they're referring to again. When they say, I don't know why I cut that out, but okay. That is what they're referring to using that formula. Okay, so just take the box out here. It's a bit shabby. Okay, so this formula will be used so often that you will start memorizing the formula. Okay, so don't be dependent on the formula sheet. Alright. So when they're talking about using the formula cos of alpha minus beta, we know that it's going to be cos of alpha, cos of beta plus sine of alpha, sine of beta. So the question says the derivation of cos of alpha plus beta is equal to that. So normally they would ask you to derive or prove. Okay. They ask you to prove, and then we do the following, or we derive, we do the following. Of course, this is an identity, so again we work with the left-hand side. Okay. So the left-hand side is cos of alpha plus beta. But remember, we need to have it looking like cos of alpha minus beta, but there's a plus here, not so. So how do we get the minus there? By saying cos of alpha minus beta. Now minus beta becomes positive beta there, alpha plus beta. So again, I haven't changed the value of anything here. So now in alpha's place, I have alpha, and in beta's place, of course, we have minus beta. Okay, so there's going to go minus beta, and there's going to go minus beta. So our formula is now going to read cos of alpha, cos of minus beta. Why? Because in beta's place we have minus beta, and sine of alpha, sine of minus beta. But then you're going to ask again, what is going to happen to that negative? That was the question yesterday. What's going to happen to this negative? But nothing's going to happen to that negative. Why? Because that is already part of the identity. Okay, that is what the identity reads. Alright, so let's go back there. We say, okay. So we do the cos expansion. So it's going to become cos alpha, cos of minus beta, plus sine of alpha, sine of minus beta. Now, many don't work with a negative angle, so always have a positive outlook on life. So that's going to be 360 minus beta. Remember, if the angle is negative, I just add 360 till it becomes positive. The angle is over 360 degrees, we just subtract 360 degrees from that. So that takes us, of course, to all stations to Claremont. That's 360 minus, that takes you to the fourth quadrant. Cos is positive in the fourth quadrant, so it's simply cos of alpha, cos of beta, right? So we got sine of alpha. So sine 360 minus in the fourth quadrant, sine is negative. So negative sine beta, making that positive and negative. Negative sine beta. Okay. And this is equal to the right hand side. So now this becomes another identity. So remember, we got cos of alpha plus beta. It's going to become cos of alpha, cos of beta, minus sine alpha, sine beta. Okay? And the original one was cos of alpha minus beta is equal to cos of alpha, cos of beta, plus sine alpha, sine beta. So there are two identities now that gets added to your identity list. Okay? So let's carry on. We need this here for the next one as well. So now we are told the derivation of the sine alpha plus beta using the original identity, which is cos of alpha minus beta, which is equal to sine cos of alpha cos of beta plus sine alpha sine beta. So again, we need to convert or change a sine 90 plus beta to look like cos of alpha minus beta. Why would I want it to look like this? So that I can apply that rule there. Okay, that's the reason why. So we know that again, let's call this the left hand side. So sine alpha plus beta can be written as, if I have to write it as a cos, then that would simply be 90 minus whatever that angle is, which is alpha plus beta. Now the first example there that we did was something similar, which is your co-function. Okay, if I'm going to go with the co-function, I'm going to land up with that again. I'm not going to come close to this. Okay. So what they say is, yes? Yes? You're talking about this one? No. Okay. So firstly, we're going to get rid of this bracket here. So what do? Is we now say this is going to become cos 90 minus alpha minus beta. So what do we have in alpha's place now? What do we have in alpha's place? Oops, sorry. What do we have in alpha's place? 90 minus alpha. Minus is on its place, as you can see there, and beta is in its place, in beta's place. Alright. So we're going to go with that expansion now. So it's cos alpha minus beta. We said it can be written as cos of 90 minus alpha, cos of beta, plus sine 90 minus alpha, cos beta. So sine beta, sorry. Okay? So again, 90 minus, that takes us to quadrants, as all stations to Claremont. There's 90 minus is in the first quadrant. So cos will change to sine there, so it's sine alpha, cos beta, plus 90 minus is in the first quadrant, all is positive, but changes to cos, that's your co-function, or co-ratio, which is sine beta. And as you can see, you've got sine alpha cos beta plus cos alpha sine beta. Alright, which is equal to the right hand side. And the last one, here again, remember initially they told us using the cos alpha minus beta equals cos alpha cos beta plus sine alpha sine beta. We must use that to derive a formula for sine alpha minus beta. Okay, so again, this is the left hand side here, which is sine alpha minus beta. Remember, we needed to look as cos of a double angle, or a compound angle, sorry. So that's going to become cos of 90 minus alpha minus beta. So let's get rid of the inner bracket. I'm now going to give you cos 90 minus alpha plus beta. But remember what we have here? We have the negative. So it's cos 90 minus alpha minus minus beta. So what is on alpha's place? 90 minus alpha. What's on beta's place? Minus beta. Why am I looking at it like that? So that I can identify with that formula there. So it's going to become cos of alpha. So it's going to become cos of 90 minus alpha times cos of beta, so it's cos minus beta, plus sine of alpha, which is 90 minus alpha, sine of beta, which is sine minus beta. Okay. Alright. So what do we have now? We go to all stations to Claremont diagram, the past diagram. So that is going to be 90 minus. 90 minus, that is co-function, co-ratios. 90 minus is going to change to sine, since all is positive in the first quadrant. That is going to, of course, be 360 minus beta, which is in the fourth quadrant, and cos is positive in the fourth quadrant, or if you were using negative angles, there's no problem. You don't need that 360. There's just cos of beta. 90 minus, takes you in the first quadrant, sine is positive, so it's sine alpha, and then minus beta is in the fourth quadrant, or 360 minus beta in the fourth quadrant. Sine is negative, changing that positive to a negative sine of, sorry, that's supposed to have been cos, sorry about that, cos alpha and sine beta, okay, which is equal to the right hand side. Alright. So in general, if we're looking at the sine expansion for the compound angle, we know that sine alpha plus beta is going to be, the ratios are different, so the sign is the same. So it's sine alpha cos beta plus sine beta cos alpha, or cos alpha sine beta. Okay? And if this is minus sine alpha minus beta, can be written as sine alpha cos beta minus cos alpha sine beta. So there's another formula that you will add to your identities. Okay? And normally this question comes in for 3 or 4 marks.